Okay, welcome back. We continue from where we left off. So let's look at the book again. What part we were doing. We have to find the EA and IA for this particular machine, and we have got some parameters that we know, some parameters that we don't know. So we need to find this phasor diagram, and in this phasor diagram, we knew V phi is 208 angle 0. We knew the IA leading angle, which was cos inverse 0.8, but we don't know EA and its angle and IA jxs magnitude. Okay, so in order to sketch this, we need to find these other parameters, as it also says find IA, IL, and EA. So we were doing this on the
सर
whiteboard.
स्क्रीन विजिबल नहीं हो रही है सर.
ओके, व्हाइट बोर्ड अभी मैं शेयर करा रहा हूँ. ठीक है जी, व्हाइट बोर्ड अब आपको मैंने शेयर करा दिया, अब चीजें विजिबल होंगी. So we know that for the synchronous motor, EA plus IAJXS is equal to the terminal voltage. We already know that this voltage is 208 angle 0, and EA I don't know, and JXS is 2J, because I know the value of XS is given in the question is 2 ohms, no 2.5 ohms actually, 2.5 J, or I can also write 2.590. So this is the value of JXS, but IA is not known to me, and I need to know IA because I need to plug in here to find EA. But I do know that IA magnitude is unknown, but I know the IA angle is, this angle is cos inverse 0.8 with a plus sign because it is a leading angle. Okay, so quickly tell me what is cos inverse of 0.8. Sorry, this is not the magnitude, this is the angle. Okay, so please make this correction. I know the angle is equal to this, but IA magnitude is not known. But I do know that P out is 15 horsepower multiplied by 746, and I do know that P in is equal to P out plus losses. So I can know P in is equal to 15 into 746 plus the losses are given to me, and the losses are given as core losses are 1 kilowatt, friction losses are 1.5, so they are 2.5 kilowatt or 2500, and copper losses are negligible because IARA is taken as 0. So this is equal to Pn, and I also know that Pn is equal to under root 3 V line, and since it is delta V line and V phase are equal, and this is equal to I line, and this is equal to cos of theta, which is equal to 0.8. Okay, so I can find IL from this relationship. Quickly tell me the value of IL. Quickly tell me the value of IL. From this relationship, quickly tell me the value of IL. Quickly. What is the line current in the armature? So I have an answer from Anam Shafiq, 48.43. Okay, so IL magnitude is 48.43, but since this is a delta connected machine, I phase will be equal to I line divided by under root 3. Quickly divide this by under root 3 and tell me the answer. Because this equation I have to put in per phase, so I have also to put the I armature current per phase. If you divide this by under root 3, what is the answer? Quickly tell me. 27.96. 27. Okay. So this is equal to 2.5. This 27.96. And what is the final answer here? Quickly tell me. what is this gadget and this gadget product equal to, and what will be the value of EA. Quickly tell me the value of EA. EA कितना आता है? Okay, so get this gadget, subtract it from 2080 and you get the final answer for EA. Quickly tell me what is the final answer for EA, both the magnitude and the angle. Quickly tell me on the chat window. Quickly tell me on the chat window. नहीं निकाला अभी तक किसी ने? EA कितना आएगा? Armature induced voltage per phase कितना आया? No one has found? Okay, just multiply this by this gadget, subtract from this gadget, and you get the answer. Okay, so I have some answer from Babar Ali. 256 angle 167. Babar, if you look at the diagram, it looks like this, that this is V5 and then you have a leading power factor. Okay, so EA is something like this and IAJXS is like this, okay? So you can see it that the angle of EA has to be some negative angle and it is not not a positive angle and it cannot be very high angle like this. So this answer looks good. Asadullah says it is 256 and the angle is minus 12.6. Okay, and many other students like Sumro and Amir Noor also have the same answer. So let me check in the book and this answer is correct. The book says 255 angle minus. So this angle is correct. Okay. So this answer is correct. EA is correct. Now let's quickly go back to the book and what can we find now? So now we can also label this phase diagram. Okay. Quickly go to the book. Here's the book. Okay. And in this question, we had a practice of all the power relationships also and the electrical relation. Assume that the shaft load is now increased to 30 horsepower. Sketch the behavior of the phasor diagram in response to this change. So you are going to repeat the phasor diagram for this new power and then you can report the change that the motor has become uh, leading power factor or lagging power factor or there is a change in the torque angle, so you can easily do this. I don't need to do this. So part A and part B are same. After the load change, you find this gadget. So this is also same as part A. Okay. So part B and C are just a repetition of part A for a different shaft load. And the new motor power factor you can obviously find. So this is the end of the lecture today. And tomorrow I will give you assignment. In the next class, you will be having an assignment, and I will also give you a complex engineering problem related to this topic of synchronous machines, and I'm going to explain you how you are going to attempt that complex engineering problem. Okay, so your assignment number 3 will be having questions from synchronous machines, and it will also be your complex engineering problem. So your this course requirement will also be done and okay, this is the end of this lecture. Allah Hafiz.